So now we'll get on to another interesting topic of the quantitative aptitude, say ratios. Ratio. It is a most common type of question that you can find in any type of quantitative aptitude testing. So what do you mean by ratio? Ratio is nothing but a fraction which is used to compare two quantities that are measured in same units. Ratio is nothing but a fraction which is used to measure two quantities that are measured in same units. Measured in same units. This is a very important aspect in the case of ratio. You can compare, say, 5 kilograms of food with 5 kilogram of chocolates. So that is possible. 5 liters of milk with 5 liters of, say, soft drinks. You can compare the number of boys in a class with the number of girls in that same class or in any other class. So this is possible. It is a fraction which is used to compare two quantities that are measured in same units. So what we have seen the representation for percentage, we have seen the representation for fractions, numbers, and so on. In the same way, what is the representation for ratio? A ratio is always represented in the form of A is to B. It is read as A is to B. Fractional representation of the ratio is nothing but A by B. A by B. A is to B. This is the representation in the ratio form, and this is the equivalent fractional representation form. Okay, so consider, we'll have a small example. Say there are 20 boys in a class, and in the same class there are 40 girls. So there are 20 boys and 40 girls in a class. You need to find out the ratio of boys and girls in that same class. So how will you represent boys and girls? As I said, ratio is in the form of A is to B. Now boy is to girl, boys is to girl. So just say number of boys is to number of girls. So number of boys is to number of girls. What is the equivalent fractional form? Number of boys by number of girls. You read it as 20 is to 40. Now this fraction can be simplified. How will you simplify? You can cancel out the zeros and it can be written as 2 by 4. Similarly, the ratio can be reduced to simple form. Any ratio can be reduced to the simplest form, but you need to divide out both the both the numbers by the same factor. So in this case, you can divide by 20 on both the sides. You will get 2 is to 4. Still it can be reduced. That is, dividing by 2 on both the sides, 1 is to 2. So 1 is to 2. So what is the ratio of boys to girls in this particular class? It is nothing but 1 is to 2. So what can you analyze from this? This is the simplest form. You need to understand that this is not the exact number what is found in the question, but the ratio 1 is to 2 is nothing but it is equivalent to 2 is to 4 or 20 is to 40. Fine. And 1 is to 2 can be represented in the fractional form also. What is the logical meaning that you can understand from this? Nothing. The number of girls is twice the number of boys. That's it. The number of girls in the class is twice the number of boys. In terms of percentage, which we have seen in our other modules, what in terms of percentage, it is nothing but say the number of girls is twice more than that of boys. Something around, you can say 100% more than boys. So this is the ratio representation. From this you can understand that any number which you are going to derive from 1 is to 2 is in the form of 1x 2x. Fine. 1x is to 2x. The number of boys can be 1x and the number of girls can be 2x. What is this x? If x is 10, what is the number of boys then? 10. What is the number of girls? 20. If x is 10, then the number of boys will be 10. Number of girls will be 20. If x is, say, 20, if x is 20, then the number of boys will be 20 and the number of girls will be 40. So in the case of ratio, if you want to find any number or any quantity that can be derived from the ratio, it can be represented in the form of 1x or 2x. That is, a is to b is nothing but ax and bx. So see, 1 is to 2, 2, 4, and say here you are multiplying by 2. X is equal to 2, a and b. So ax is 2. 2 into 1 is 2, 2 into 2 is 4. Similarly, if x is 10, ax is nothing but 10, bx is nothing but 20, and so on. So it is given here, the Indian team has won and lost the matches in the ratio 7:3 respectively. That is, they have played a number of matches in that the ratio of winning is to losing is 7:3. Given the fact, you are asked to find what is the percentage of matches that they have won. So this is something interlinking of several modules what we have seen. It is very easy. 7:3. What is the percentage of matches that they have won? You can consider in any form, as I said. Say if you are considering for 100 matches, just take it as 100 matches. 100 matches in the ratio of 7:3. If you want to get the sum as 100, you need to represent as 7x and 3x. So 7x plus 3x must be is equal to 100, in the sense put x is equal to 10. 70, 30. Since they have asked what percentage did they win, as we have seen in our other modules, keep the base to 100. Whenever a question on percentage is asked, you can keep the base to 100. The ratio given is 7:3. That is, they have won the matches in the ratio of lost the matches in the ratio of 7:3. Keep 100 matches. How will you obtain the sum of these two as 100? By multiplying 10 on both the sides. As I said, represented in the form of 7x and 3x. 7x plus 3x is equal to 100, in the sense x must be 10. So 70:30. So this is a direct representation of the percentages. The percentage of matches that they have won is 70%, and the percentage of the matches that they have lost is 30%. Fine. Okay. So this is a sample, a good example for representing ratios in terms of percentages. Whenever a question is asked on percentages, keep your base to 100. 100 in terms of 7:3 is nothing but 70:30. So 70% of the matches has been won. Vice versa. If a question is given in terms of percentage and you are asked to represent in terms of ratios, the same procedure for, say, in a class, 45% of students are male. Okay. What is the ratio of male is to female? Female students in the class. Okay, fine. So it is given 45% of the students in the class are male, and you are asked to find the ratio of male is to female. As I said, when a question is asked in percentage, formulate or base your question to 100. Fine. We will consider that there are 100 students in the class. In 100 students, 45% are male. In the sense, 45 are male. The remaining is 55. So 45:55. 45 male students and 55 female students. You can reduce to the simplest forms. How? 45/55 is nothing but 9/11. So in terms of simplest forms, the ratio of boys and girls, or the male and female students in the class, is nothing but 9:11. So keep your base to 100. Get your answer, formulate to the simplest form, 9:11. Now say there is a group of n objects given. You are given a group of n objects. A set of objects is given. A set of objects is given. Now you want to divide this particular set of objects in the ratio, say A is to B. Fine. A set of objects is given and you want to divide the set of objects in the ratio of, say, A is to B. So divide the set of objects in the form of A is to B. Divide so. So divide the set of objects. To divide the set of objects in the ratio A is to B, partition such that each group contains A by A plus B element and B by A plus B element. If you are dividing your given set of objects in the form such that each group contains these number of elements, it means that you are dividing the set of objects in the ratio A is to B. As we have seen in our previous example, say a group of 100 objects is given. A group of 100 objects is given and you want to divide it in the ratio of 9 is to 11. So 9 is to 11 in the sense, divide 9 by 9 plus 11 is 20 and 11 by 9 plus 11 is 20. So 9 is to 11 in the sense, we initially you can consider there are 20 students in the class and you can divide them into two groups, say 9 by 20 and 11 by 20. How did you derive this thing? A by A plus B and B by A plus B. But is that necessary that there should be only 20 students in the class? It is not so. There can be any number of students, say 40, 60 or 50, whatever it is. But whatever may be the case, it is nothing but a constant multiple of this particular ratio. It can be, say, 9 by 20. If there are 40 students in the class, multiply by x. X in the case here is 2. So if x is 2, it will be 18 by 40. 18 by, similarly the number of girls, 11 by 20. If x is 2, 22 by 40. By dividing the boys and girls in this ratio, you can obtain 9 is to 11. Now what will you do in the case of three ratios? A is to B is to C. You are given a set of objects, similarly a set of objects. And you are asked to divide it in the ratio A is to B is to C. A is to B is to C. Say you are having a set of 100 or you have a set of 100 popcorn bags in your hand. And the sizes of the popcorn bags are, say, small, large and jumbo packets. You want to divide the popcorns as small, large and jumbo packets. So A is to B is to C. In this case, similarly, as we have seen, divide it in the form of A by A plus B plus C and B by A plus B plus C and C by A plus B plus C. Fine. So if you are having, say, around 90 popcorn packets, fine, 90 popcorn packets, and you want to make, say, 5 is to what to say, the ratio of 5 is to 7 is to 10. If you want the packets to be arranged in the ratio 5 is to 7 is to 10, each one will contain 5 by 5 plus 7 plus 10, 22, 7 by 22 and 10 by 22. For 90 popcorn packets, multiply 22 by x, 5 by x, and the x value should be in such a form to get 90. So to divide into three groups, A by A plus B plus C, B by A plus B plus C and C by A plus B plus C. I hope it would be clear. Here it is given as Ranil had 240 bags of chocolates. Ranil had 240 bags of chocolates. Now in those bags of chocolates there are many sizes. They are given as small, large and jumbo packets. Small packets, large packets and jumbo packets. In what ratio they are arranged is 8 is to 17 is to 15. The ratio of super to large to jumbo bags of chocolates that Ranil had is 8 is to 17 is to 15. 8 is to 17 is to 15. What is the total number of bags that they have given? 240 bags of chocolates. So the total number of chocolates given, bags of chocolate given is 240 bags. The ratio is 8:17:15. We are asked to find the number of small packets, number of large bags, number of jumbo bags. So as I said, write down the ratio 8, 17, 15. Okay, 8, 17, 15. We do not know by multiplying, and we can write 17x, 15x. As I said, any ratio can be, to find the total number of required elements, just multiply by x. 8x, 17x, 15x. So 8x plus 17x plus 15x must be equal to 240. Fine. 8x plus 17x plus 15x is equal to 240. This is the basic concept. For any given ratio, the sum should be equal to 240. How it would be equal? By multiplying each element with a constant, say x. Adding them must be equal to 240. So 10, 20, 40x. 40x is 240. X is 6. So if you multiply 6 with each element, you will get 240. So x is equal to 6. Now we have to find the number of small packets to the large packet to the jumbo packets. That is okay. So x is equal to 6. 8x is the number of small packets. 17x is the number of large bags. 15x is the number of jumbo bags or jumbo packets. So 8x. X is 6. 8 into 6. 48. 17x. So 17 into 6. It is 102. 15x. 15 into 6. 90. Right? For 48 small packets, 102 large, 90 jumbo. What is the other method for finding? You need not go for so many tasks. Instead, just add all these things. 17, 15, 8 is 40. So find the total number, 40. 40 into, to find the number of small packets, take the ratio 8. 8 by total value 40 into the given number of bags, 240 is equal to what? 48. 8 into 6 is 48. Similarly, 17. To find the number of large packets, 17 by 40 into total number of bags, 240. Answer is 102. Similarly, for jumbo, 15 by 40 to 240. Answer is 90. So even in this way you can proceed, or you can take the unknown value as x and do the same thing. This would be more comfortable. Take the ratio, divide it by the sum. 8 plus 17 plus 15 is 40. So 8 by 40 into total number of packs, 240. So 48 is the answer, same value. Now how to compare two ratios? Say it is given as 2:3. In another thing it is given as 4:7. How to compare these two ratios, 2:3 and 4:7? Which one is greater or which one is lesser? To find out, to compare two ratios, convert them into fractional form. 2/3, 4/7. Okay, 2/3 and 4/7. You want to compare this. Just cross multiply the numerators and the denominators. 14. 7 into 2 is 14. 3 into 4 is 12. You want to compare two ratios, 2:3 and 4:7. Write this ratio in the fractional form, 2/3, 4/7. Cross multiply the numerator and the denominator. 2 and 7, 3 and 4. 2 into 7 is 14, 3 into 4 is 12. Now observe, which one is greater? 14 is greater than 12. 14 is greater than 12. Just see the value above. Which ratio corresponds to 14? 2 by 3. 14 is below 2 by 3. So 2 by 3 is greater than 4 by 7. You need to compare two ratios, 2 is to 3 and 4 is to 7. Write them in the fractional form 2 by 3 and 4 by 7. Multiply the numerator and the denominator. 2 into 7 is 14, 3 into 4 is 12. Just observe the ratio that is above the value. Which one is greater? 14 is greater than 12. Which ratio is above 14? 2 by 3. So 2 is to 3 is greater than 4 is to 7. So this is the shortcut method of finding which is the greatest ratio.